All right, we're going to go ahead and look at a geometric sequence. So let's look at the pattern 2, 4, 8, and 16. If you look at the table down here, we're going to use this just to display the exact way of doing this. So you'll notice that we have the value of 2, 4, 8, and 16, and we're going to look for the pattern that is set. Well, this is an easy one. You should see that we are multiplying by the value of 2. So example, if I take 2 and I multiply it by 2, that will give me 4. If I take 4 and I multiply it by 2, that will give me the value of 8. Easy pattern to find for most people, okay? But as we do this, we want to kind of go understand, well, how are we going to do this if the numbers were a little bit different, okay, or a little bit more complicated? So what we do is we find the common ratio. And when we find the common ratio, that is what we'd say is term 2 divided by term 1. And that just simply means we take the term that we have now and we divide it by the one that is previous to it, okay? So the one we have now, for example, would be like 4. And let's take 4 and we are going to divide it by the one that is previous to it, 2. 4 divided by 2 is 2. So we multiply by 2. And we can continue to do this. 8 divided by 4 is 2 as well. So we multiply it by 2 to get from 1 to the next. And we would verify this over and over and over again, just to make sure that our common ratio is the same every single time. So 16 divided by 8 is times 2. And once we know that pattern is set, we use that pattern to continue. So we take times 2, we multiply by 2, our common ratio, that gives us 32. 32 times 2 gives us 64. And 64 times 2 gives us 128. And what we've done is we have set the values and we have set the pattern. So our common ratio in this case is simply 2. Now we also have our sequence, which we finished in our table. So we could just write that in times 2 all the way across. And then we can continue. 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. All right, there we have it. Those are our common ratio and our terms. Now, the hard part is coming up with this recursive formula, okay, or a recursive function that we've written. Remember when we start our recursive function, we are going to start with a starting point. So we start here at 2, which is our first term. Okay, so when we write this down, we're just simply going to write, okay, well, we start with a sub 1 equals to the value of 2. And that's how we always start a recursive formula. We start with the initial point that is given to us. And then what we're going to do is we're just going to simply write what is happening to that term. So when we do that by saying this, a sub n, which is kind of like saying, what are we going to get next? It's equal to what we have now, or an minus 1. This is kind of like saying what we have now. Okay, and what are we doing to it? We are multiplying by 2. So we start with our first point, and then what we do is we say, in order to get what we have, what we want next is we take what we've got now and we multiply it by 2. Okay, and we just keep working it from there. As discussed in some of our other stuff, geometric is just another, it's just a discrete way of doing an exponential. So we can write an explicit function very easily just by using the exponential equation. So let's go with an exponential, which is y equals to our multiplier, which is our common ratio of 2 to the x. And what we need to do is we need to find the initial value. Remember, this is the initial, or when the term is 0. Okay, so the term is 0. And the issue with this is we have our first term. And so watch our pattern. We're multiplying by 2 in this direction. So in order to go backwards, we've got to divide by 2. Okay, so we've got to divide by 2. So if I want to know the initial or the 0th term, I'm just going to divide back by 2. 2 divided by 2 is 1. So our first or initial term is 1.